Hello everyone, today we are going to start lecture 5 related to chapter 5 of electricity grade 9. So I hope that as usual all of you are doing well in your studies. So resistivity is the topic of today's lecture. So what is resistivity? Because before understanding resistivity we need to understand that on which factors resistance depends. So factors which affect the resistance is the length of the material. Okay, so longer materials have greater resistance. If the length is very huge, definitely large amount of atoms would be there, and definitely the position faced by the electrons, it would be greater. So if there is huge length, definitely the flow of electron will face more opposition because more atoms are there in the conductor. The cross-sectional area of the material. Large areas offer less resistance. If the area is huge, definitely there would be more space for the electrons and they will move with greater speed. So they will face less opposition. And number third is that the temperature of the material. The resistance depends on the temperature. The higher temperature usually result in high resistance. So definitely if we increase the temperature of the resistance, okay, so definitely what will happen, that increasing the temperature, the atoms inside the conductor, they will start moving. Okay, when they move, definitely their movement will also stop the movement of the electron. So definitely when they are moving inside the conductor, because of the higher temperature, the electrons will face opposition in their flow. So the higher temperature will also increase the resistance. So resistance have a direct relation with that of temperature. The kind of material, okay, iron has, for example, this resistance also depends on the material. Like for example, iron has more electrical resistance than a geometrically similar copper conductor. So iron resistance is more as compared to copper. So that's why copper is used in wiring and electrical wiring, because iron is not used because electrical resistance is very high. So definitely it will waste a lot of energy. So we can say that resistance of a wire is directly proportional to the length of the wire. So we can form a relation between the resistance of the wire and length of the wire, showing the direct relation. And the resistance of the wire have inverse relation with the area. And combining these two above relations, we get or have a direct relation with length but inverse relation with area. Combining these two relation and removing the proportionality sign, we put a constant value, and this constant value is called resistivity. And resistivity is represented by a symbol rho, R-H-O, rho. So what is electrical resistivity? Where P is the rho is the resistivity of the material. Unlike resistance, resistivity only depends on the temperature. So resistivity is more specific. Okay, resistivity is more specific and it only depends on the temperature. Its unit is ohm meter. So resistivity can be found by arranging the formula for resistance, that is R multiplied by A over L. So the resistivity of the metal increases at high temperature. For most other materials they increase. So keep in mind that resistivity of the material only depend on the temperature, while resistance depend on the area, length, temperature and the kind of material. So unlike resistance, the resistivity only depends on the temperature of the material, and moreover the unit of resistivity is ohm meter. So let's do some question related to the resistivity. Calculate the resistance of a wire, copper wire of length 2.3 meter and cross-sectional area of 1.5 into 10 raised to the power minus 9 meter square. Copper has a resistivity of 1.6 into 10 raised to the power minus 8 ohm meter. So length is given, that is 2.3 meter. Area is 1.5 into 10 raised to the power minus 9 meter square. Resistivity, which is a constant value for each material, they have specific resistivity value. So copper resistivity is 1.6 into 10 raised to the power minus 8 ohm meter, and we need to find the resistance. So we know that resistance is equal to resistivity L over A. Putting the value in the equation, we get the resistivity resistance to be 2.45 into 10 raised to the power minus 1 ohm or 0.245 ohm. So copper has a very small resistance. So you can see this copper resistance. That's why copper is used in wiring, because of its less resistance. Question number 2. Calculate the resistance of a glass rod of length 24 cm and radius of 4.0 mm. Glass has a resistivity of 1.0 into 10 raised to power 8 ohm meter. So you need to find the resistance of a glass rod. So glass rod length is given, that is 24 centimeter. We need to convert all the centimeter values into meter. So definitely 24 divided by 100, it comes out to be 0.24 meter. Radius is given, that is 4 millimeter, that is 4 into 10 raised to power minus 3 meter. But we don't know the area of the glass rod. So definitely area of the glass rod of any cylindrical object, it is equal to pi r square. Putting the value in the equation, the area come out to be 3.14 multiplied by 16 multiplied by 10 raised to power minus 6 meter square. Calculating and after doing proper calculation, the area of the glass rod comes out to be 5 into 10 raised to power minus 5 meter square. Now we need we have resistivity of the glass is given, and we need to find the resistance. So we know that resistance is equal to resistivity multiplied by length divided by area. Putting the value in the equation and doing proper calculation, the resistance of the glass wire comes out to be 0.048 into 10 raised to power 3 ohm, or it is equal to 48 ohm. So 48 ohm resistance is quite large for glass. So glass resistance is very high. So that's why it is not used in electrical wiring, because its resistance is very high. So that's why it is a poor conductor. So the flow of electron inside glass is almost impossible because its resistance is 48 ohm. So question number 3. Calculate the resistance of a copper wire 1.0 kilometer. So copper wire length is 1 kilometer long and 0.5 millimeter diameter. If the resistivity of copper wire is 1.7 into 10 raised to power minus 8 ohm meter. So converting all units into meter, we get length 1 kilometer. So 1 kilometer is almost equal to 1000 meter, or we can write 10 raised to power 3 meter. And diameter is given, that is 0.5 into 10 raised to power minus 3 meter. So if R is the radius of the wire, the cross-sectional area, we know that the cross-sectional area of the wire, because wire can be taken as a cylindrical object. So we know that area of the wire should be A is equal to pi r square. And here we don't know the radius. So definitely radius is equal to diameter divided by 2. So we can say that the area of wire is equal to pi d square over 4. So definitely putting the value in the equation and doing proper calculation, we get the area of the wire to be 0.2 into 10 raised to power minus 6 meter square. So resistance can be found by putting the value in the formula and doing proper calculation. We got the resistance of the copper wire to be 85 ohm. So definitely now let's see this 85 ohm resistance is very huge. Why it becomes greater? Because the length of the copper wire is 1 kilometer. So it is very large length. So definitely we know that the resistance of the wire, it depends on the length. The greater the length, the lesser would be the resistance. Sorry, the greater the length, if the length is higher, the resistance would be higher, sorry. So definitely with the increase in the length, the resistance would also get increased, because the electrons would face opposition in their flow. So you can see over here that 1 kilometer of copper wire will have a resistance of 85 ohm. So I hope that you have understood the lesson. Do study, do practice the questions, stay happy, and take care of yourself.